Throughout history, people have been looking for better ways of doing work, and the idea of process improvement has been around for a very long time. I'd like to give you some perspective about the specific history of the methodologies that we're going to be using for this class, which are Lean, Six Sigma, and the theory of constraints. As we've discussed in class, many of these ideas and principles were sort of born in manufacturing settings. Primarily, many of the innovations took place in the automobile industry. So the examples that I'll be showing you in this presentation come from the automobile industry. It's important for you to recognize, however, that what we're talking about is improving processes, and processes occur in every industry, in every task, in every business. So the principles that we learn from this class, although they were born out of and thought of many times in a manufacturing setting, they are equally applicable in service industries as well, and used extensively in services. Before heavily mechanized production, items were produced using a method that we'll refer to as craft production. You can imagine going to buy a car, and here's a picture of one here, or perhaps going to buy a suit or an article of clothing. You would go to a small workshop, a small company, usually family owned. These would be small family businesses, mostly made up of family members. The production took place in very small production areas, usually an outbuilding or inside of someone's house. So it might be, you might think of it as in someone's garage or in someone's barn or in a building that was on someone's property. The people that were in that business would use small, inexpensive, common equipment, things like hammers and saws and drills and small general purpose production equipment to produce whatever it was that needed to be produced. And here's what would happen. You as a customer would go into this business and you would tell the owners of the business exactly what it is that you wanted. What you wanted it to do, you wanted it to look like. So if it was a suit, you'd say, this is the purpose of this item. This is what I want. This is the colors that I want, the sort of features that I want on it. Here's where I want pockets. And then the owners of the business would design that product for you. They would give you a price quote and tell you, okay, we'll work on this and get this back to you in a while. And then they would go about doing the entire supply chain activities that needed to happen to make this, this production occur. So within this business, they would design that product. They would do all the procurement, buy the materials for that. They would get those in and begin making changes to those and shaping them and stitching them together and blending them together to make them work. So every single piece that they made was custom produced, a one of a kind. They would use this small production space, and then the people that were in the business would do all of that work. So all of the employees in the business, the members of that family typically is what would be involved there. They would do everything. Sales, design of products, procurement of materials, fabrication or production, and then after sales service as well, doing repairs and upgrades to whatever it was that you had purchased. Typically, workers in a particular craft production business would be family members, and so if your parents were owners or workers in a particular type of line of work, then you would be expected to go into that line of work as well. And as you grew up, you would learn how to do that type of business. If you wanted to break into a different type of business as a worker, then you would progress through learning that business in an apprenticeship. So you would appeal to whoever the business owner is, you would go to them. They would take you in, you'd get a stipend pay, and then you would learn the business right along with those business owners and in effect become the business or the process expert. You would learn the entire business from the ground up from that particular business owner. I'm going to be using this process matrix to be able to describe the differences between the different type of production systems that we'll study in this class. It's going to be especially important for us to understand the fundamental differences between a mass production system, which is listed here, and a lean production system, which we'll be describing in this handout. But lean production really was taken as kind of a blend of craft production and mass production. It's not a true blend, but ideas and sort of the best pieces from both of them were sort of blended together to create this lean production system that we'll be talking about later in this production handout. So let me walk through with you the fundamental characteristics of craft production as we've just seen. So there are these different characteristics, labor specialization, labor knowledge, and you can see the rest of those there. It is going to be important for you for exams to understand the different characteristics of each of these different production systems. So let's walk through each one slowly. First of all, craft production. Labor specialization was low. So here's what I mean by labor specialization. Labor specialization is when you hire a particular worker to do a very small part of a particular job. So their job is specialized. They're only doing one specific thing. In craft production, labor was not specialized at all. In fact, as we just discussed, every worker does everything. So every worker is responsible for doing a variety of different tasks to be able to produce whatever product it is that was being produced. So labor specialization was very low. As a result of that, labor knowledge was very high. So the workers in a particular business would have extensive knowledge about every part of the business. They would know exactly who the customer was. They would have met the customer. They would have been involved in the product design. They would have been involved in the procurement of materials to make that particular product. They would know how to produce every part of that particular product. If they went into their workshop and they saw what we would call work in process, or they saw different jobs that they were working on in different stages of production, they would know exactly what had been done, who had done that work, and what needed to be done next. If a customer brought in a product for after sales service and to make a repair or make an addition or a modification to that particular product, then the worker would know the customer and know that particular product and would be intimately knowledgeable about what had happened. In fact, that worker probably would have been the one or one of the people that had actually worked on that product that they brought in. Now, because of the nature of craft production, every single product that was produced was unique and one of a kind. So product variety was really infinite. They could make anything. Now, as long as they had the skills, the materials, the experience needed to produce whatever it was that the customer wanted, they could produce anything. And so product variety was infinite. And volume, I'm putting here, product volume is one. So they would just make one of a kind. Now, you might come in and you might say, I want two suits. Two business suits, and here's how I want them designed, and here's the features of them, and I want them to be exactly the same. But keep in mind, those were being made one at a time, and they were being made by hand by very basic equipment. And so even if they were trying to make two identical products, there would be differences between the two products. So that's why I say product volume is one. Even though they may make two of a particular thing or three of a particular thing, typically volume is very slow, very small. Similarly, the space that was required was small. Remember, these were businesses that took place in people's homes or in outbuildings, so it didn't require a whole lot of space. They didn't have a whole lot of inventory. The equipment that they were using was typically small and general purpose, so they were able to do their work in a very small, confined space. I mentioned before the tools that they were using were inexpensive, typically general purpose for whatever that particular industry was. The process speed was slow and was determined by the worker. So because the workers were really the owners of the business, then the workers could determine how quickly they would work. If they wanted to get a job done quicker, they would work faster. If they wanted to take their time on a particular part of that process, then they would work slower. It was completely determined by them. They were the owners. They could make all of those decisions. You can imagine that production lead times were very long. It could take weeks or months to receive a product that you ordered, and that was determined again by the worker. Quality and product reliability was also dependent on the worker or dependent on the business. You would make a decision as a customer about where it is that you would go to procure whatever the product was that you wanted. There were different businesses in town. Some of the businesses had more experience or had reputations of being high quality production businesses, and so you could make a choice to go to an experienced business, or you could go to someone who was an apprentice or recently apprenticed that didn't have as much experience, and then the quality that of the product that you received might not be as consistent as something that you might see other places. Quality and product reliability also was somewhat inconsistent because every product was custom designed, one of a kind, and so sometimes there were problems with a product that was produced. Improvement was also unpredictable and initiated by the worker. So again, the workers were the owners of the businesses, and many times were the owners of the businesses. If they saw that that there was a process and they envisioned a way of improving that part of the business, and that's something that they wanted to do, then they would do that. If they didn't want to, if they liked the way that the business was running, then they would just leave it the way it is. It was completely initiated by the worker, by the owners of that particular business. And so there wasn't necessarily a set schedule for making improvements or method for making those improvements. The workers would make all of those decisions on their own. In the early 1900s, Henry Ford developed what is referred to as the Henry Ford production system or the Ford production system. We'll be referring to it as the mass production system, and this really became the standard for world-class production for many decades. This system was really developed from two innovations that had occurred around the turn of that century, around the year 1900. One was Eli Whitney's innovation. Now we know Eli Whitney, typically we think of Eli Whitney as being the inventor of the cotton gin, but his real innovation that allowed for Henry Ford's mass production system was the idea of standard interchangeable parts. So up until this point in craft production, if you were making fasteners or fastening two pieces of metal together, then you just custom fashioned a fastener, a way of fastening those two pieces together. And it might be a screw or a clamp or some sort of other mechanism to attach those two pieces together. But then if that mechanism broke and you had a customer come in to replace that, you'd have to take measurements and recreate that from scratch because it wasn't made to any particular standard. Well, Eli Whitney had the idea that, well, why don't we, for standard fasteners, why don't we make those fasteners all the same or make several different sizes that might suit different needs? And then if a customer came in, for instance, if a screw or a bolt broke, then you would bring that product in and you could just buy another bolt or screw that was exactly the same, pick it out of a box and insert it in, and it would fit into your particular product. So that idea of the interchangeable part made replicating production a lot easier. The other innovation was, and it's not, his name's not mentioned here on the slide, but his name is Frederick Taylor. So around that time too, Frederick Taylor came up with the idea of scientific management. So what this meant was that you could take a job, and the job might be very complex. So something like building a car. And so the idea here is that why couldn't you take that very complex, extensive job and break it down into its most simple components? And then if you get enough people together and you just train each person to do one small part of that job, then the training would be very easy. You could improve quality because that person would become an expert at that very small task or job. For instance, you could just train someone to tighten one particular bolt on a car, and then so training them would be very easy. They could come in, just tighten that bolt. It'd be very easy to train them. They could become very good at that. Then you put them on a line, and everyone that's on that line has their own very small, particular, specialized job to do. And as long as each person does their job perfectly, then you could replicate production over and over again in very, very high volumes. And that's exactly what Henry Ford decided to. And Henry Ford really maximized the effectiveness of these ideas of interchangeable parts and specialization of labor, the idea of scientific management from Frederick Taylor. In fact, he expanded that idea to every function that was in the business, not just on the production line. So he had very specialized people that he would hire and train to be workers, of course, with specific roles, supervisors, people that would do production design, people that would do sales, people that would do deal with quality issues or housekeeping or procurement. This is really where we get many of the job functions that we have today. All of you are majoring in supply chain management. That really is a function of coming from Henry Ford's idea that we can specialize labor. So we don't necessarily have people that are general business people that do everything in the business, but we have very specialized roles. Some people do finance, some people do accounting, some people do sales, some people do marketing, and then some people do supply chain management. And even within supply chain, as you know, there are many specializations that you can go into. So each one of these business functions was very specialized, including the function of improving the business. And so improving the business was given to specialized individuals that he referred to as industrial engineers. And these were the people that were responsible for watching the process and figuring out what the best ways of doing that process were, and then directing those efforts. So they would be the people that would talk with the supervisors, who would then tell the production workers, hey, we're going to do this work differently. You're going to stand here or do this work in a different way because it's going to be more productive or it's going to improve quality. And so they were the really smart people to be able to do that sort of work. In effect, what Henry Ford was doing was turning workers into interchangeable parts as well. So for instance, if a bolt broke on a car, then you could just pull out a new bolt out of a box that was exactly the same as all the other bolts and replace that bolt right away. So similarly, the same idea applied here to where if a worker wasn't performing the way they needed to be performing, then Henry Ford would say, well, then we can just get rid of that worker and we can bring in another worker that's exactly the same that can fit into that position, because training them will be very easy because they only have a few things to think about to be able to do that particular job. So we can train them very quickly and get them up and running. So really, you would have interchangeable parts in this business, but workers were also seen as kind of parts of that production machine, and they were interchangeable parts as well. Henry Ford was known for investing in capital equipment, customized, specialized equipment that would be able to produce the component parts in high volumes that he needed for his production lines. So he would custom design these machines that would be able to produce a single component, for instance, a left fender of a car, or a back bumper of a car, or a door handle for a car. And those machines would do that one particular job. They would do it over and over and over and over again. The idea there is that the machine could produce high volume, but the parts that it would make would be identical. Every single one would be the same that came out of that machine. And of course, there were workers that were specialized in operating each of those different pieces of equipment. A lot of this equipment was very, very large. You can see in this picture, there's a worker there in sort of the lower left corner working on this machine. It's one of Henry Ford's production presses. It was used to produce some sort of a metal part. And so, of course, this also required high amounts of inventory. They would produce these component parts in very high volumes, high speed. The parts or components would be put in large bins and then needed to be stored, perhaps in a warehouse, until they were needed for a particular production run. Then they would be pulled out of the warehouse and brought over to the production line to be used in producing that particular automobile. There was also an end-of-the-line inspection. So as the cars would come off the line, there would be inspectors there looking at the cars, of course, making sure that they were operable, making sure that the parts fit together. But many of the cars would come to the end of the line and there would be parts that were missing, there would be parts that wouldn't fit properly, cars that wouldn't operate, and so these would have to be put into a rework area. But of course, Henry Ford had a solution for this as well. He had rework and fitters, quality people that would be trained in and specialized in making these repairs to the automobiles to make them operable. Because of the very large equipment, the speed of the equipment, and the large amounts of inventory that were created from this production system, Henry Ford's production processes were very, very large. These were huge production facilities, and you've got some of the statistics about one of his most famous plants here on this slide, but just huge developments that took up lots of land and lots of space, required lots of transportation of materials from place to place, and consequently needed a lot of infrastructure to be able to support that. So you see here that Henry Ford would have his own power plants, his own fire and police departments, hospitals, maintenance workers to maintain all of this equipment. So he had it all there, and he really did pursue sort of vertical integration, where he was trying to be in control. His idea was, I am the best at being able to do production, and his production process at the time really was world class, the best in the world. And so he said, I would like to be able to do all of that production. So he worked to take larger control of the entire supply chain, in effect. By the 1950s, this mass production system was considered to be world class, and people would come from all over the world to see Henry Ford's production processes, and they would learn from it. They would take it back to their countries or take it back to their processes, and they would replicate his production systems. And I'm going to tell you as well, there are many remnants of Henry Ford's mass production processes and that mindset that continues to be prevalent in work processes today. In fact, most of us sort of grew up with Henry Ford's production mindset in mind. When we think about productivity improvements or quality improvements, the context in which we're thinking is typically this Henry Ford's mass production process, which has really taken hold in our society and has integrated itself into much of everything that we do. And so we're going to be able to see that as we go through the course this semester. So now let's take a look at some of the characteristics of Ford's mass production system. First, labor specialization. Now, of course, Henry Ford used very high labor specialization. Remember, he would hire a worker perhaps to just tighten up one particular bolt on a car or do one specific job. And so the labor was highly specialized. Workers would only do a very, very small part of that particular, the overall production of an automobile. Consequently, labor knowledge was very low. So, in fact, Henry Ford wanted it this way, and he would say what he wanted is for workers to keep their heads down and just get their work done. And so if they were hired to put on a particular bolt, they didn't need to worry about what happened before the bolt got to them. They didn't need to worry about what happened when the bolt left them. They didn't need to worry about production improvements. All they needed to worry about was tightening that one bolt. And so that's all he wanted them to do. So labor knowledge, very low. Workers did not know what work happened before that product got to them. They did not know what happened once that product left them. And well, we'll see this in a minute, but Henry Ford didn't even want them thinking about or worrying about production improvements because he had specialized labor that was responsible for that. Of course, those were the industrial engineers. Now, product variety was very low. We saw this, Model T, the production lines would be set up for a very small number of variations in product. They would do very long production runs of making just one product over and over and over again. And the idea there was to make a very small number of products, but make them in high volume. So product volume, very high volume, millions of products would be produced, but they were all identical. The space required, we saw, was very large. And Henry Ford used very expensive, specialized, customized, this large equipment that was designed to produce or do one particular job, but do them in very, very high volumes. Process speed, I'll say that process speed was fast. Now, the process speed itself was determined by the manager. So the manager in the business would be the one that would determine the speed of the line. You've probably seen or heard of Henry Ford's conveyor lines that would bring the cars down the line and the workers would do the work on the car as it traveled by them. The manager, the supervisor, would be the one that controlled the speed of that line. So if the supervisor wanted work to happen faster, then the supervisor or manager would just speed up the line. And so the speed was determined by the manager. The workers had no input on how fast the production line would run. Production lead time. Now, I mentioned here production lead time is relatively long. And what I mean by that is production lead time would be the time from when raw materials come into the plant, into the loading docks on one end of the plant, until those materials get turned into finished products and then are shipped out as finished products. And you can imagine if Henry Ford is working in these large batches, this high speed, high volume equipment, he would need a large volume of raw materials coming into the plant. Those would typically be put in storage areas and would wait there for a while until time was available on a particular piece of production equipment to make a component. That material would be taken over to that machine, and then large volumes of that particular component part would be made, put into bins, and taken over to a storage area to wait again until a production process was available. Typically, there would be some sort of a subassembly that would be made, for instance, a door assembly or an engine assembly, or some other complex component would be made of a variety of different parts, and then those would be made in high volume, all exactly the same, and then stored someplace, and then those would be brought over to the production line. And of course, I mentioned at the end of the production line, many of the cars would have quality problems and would need repair. So there were large lots where these cars in need of repair would be stored until they could be fixed. And so it would take a long time to produce a car from raw material to finished good. Now, they were producing high volumes, and the cars were coming off the line at a very fast speed. But the time it took to get from raw material to finished good was a relatively long time. Quality and product reliability, I have here written down as highly variable. And so, although the idea in the mass production system would be that each product would be made identically, there were variations in the work that was made, in the work that was done, and in the way that those products were assembled together. And because of that variation in this highly complex product, this car, the quality and product reliability would be variable. So you might get a car and it would run great and it would have great quality. You might get another car, exactly the same car, supposed to be identical, and it didn't, and it would break down quite often. In fact, Henry Ford included a toolbox in the car. When you purchased a car from Henry Ford, it would include a toolbox because it was expected that at some point the car would break down, and so you would need to have some tools to be able to repair that car. I can remember, this production system, Henry Ford's production system, was replicated and used for years and years, and honestly still is by many companies. I can remember growing up as a kid, and my parents would be going out to get a car, and one of the pieces of advice that people would give when you would buy a car, again produced by Henry Ford's mass production system, was you don't want to buy a car that was produced on a Monday. So when you go to the sales shop and you're looking at a particular car, make sure you ask, what day of the week was this particular car produced on? Because it was thought that cars that were produced on a Monday would be of inconsistent quality, or perhaps poor quality, because a lot of the workers had been out drinking all weekend and would come into work on Monday hungover and wouldn't be doing the high quality work that they needed to be doing. And so the quality would suffer as a result of that. Similarly, improvement, and I mentioned this before, was done by industrial engineers, and so it was periodic, designed by management, and when the industrial engineers felt that there was a way to improve that process, then they would implement those changes. Workers were actually discouraged from making process improvements on their own. This was to be the work of the smart people in the business, those industrial engineers. The company Toyota began as a family business. Originally, the Toyota family did not produce cars. They produced looms that made cloth. In this business, they innovated and experimented and always tried to improve their business. And so many of the innovations that they came up with, we're going to be discussing in this class as innovations that really do dramatically improve productivity and quality. Eventually, the Toyota family began producing cars. After World War II, there was a lot of difficulty in producing in Japan for many reasons. And after the original president of the Toyota Motor Corporation resigned, Eiji Toyota became the Toyota company president, and Taiichi Ohno was the plant manager. These are two names that we'll hear about later in the semester, because they came up with many of the innovations that we now refer to as the lean production system or the Toyota production system. This is just a side note you might be interested in. It was something that was interesting to me. Why is it that we refer to the car company Toyota as Toyota when the family name is Toyoda with a D? And there's different theories about why this might be, and so I've listed them here just for. So in early 1950, as the Toyota company was struggling, they realized they needed to make dramatic changes in the way that they were running their business and in the way that they were running their processes if they were going to be competitive and if they were going to rejuvenate their business. So Eiji Toyota visited U.S. automobile plants specifically came to look at Ford's production system, realizing that Ford's mass production system was world class, came and spent 12 weeks learning about world class mass production. With the idea that they would take those concepts back to Japan, implement them at Toyota, and be able then to be competitive. Here's just an example of how large the Ford company had become by this time. The company Toyota had produced 2,685 automobiles over the past 13 years in 1950. So that was the total number of cars that they had produced altogether. And Ford at the time was producing 7,000 automobiles a day at just one of their production plants. And so Toyota's goal was, let's look at Ford's production system and see if we can take this back to Japan and produce similar results, of course, to be able to serve the market there in Japan. But the Toyota family realized very quickly that they were not going to be able to replicate Ford's mass production system in Japan. The markets were different, and the entire production environment was different in Japan than it was in the United States. So one thing is that Japan had a small, diverse automobile market. So in the United States, Ford could produce a large number of identical vehicles, and they had plenty of market capacity for that to be able to sell those vehicles. But in Japan, Toyota needed to produce a variety of different vehicles for a variety of different markets, and they needed to be serviced domestically. Not much of an export market, but they needed high variety. And of course, Ford's mass production system was custom produced or custom designed to be able to produce a very limited number of models just in high volume. The other problem is that Toyota had very limited capital. So Henry Ford's mass production system was capital intensive, large facilities, very large customized production equipment that was very expensive. And Toyota just didn't have that money because of the losses experienced in the country during World War II that prevented them from making purchases of this really, really expensive production equipment. Even if they had the money to be able to purchase that equipment, there wasn't room to put it. Japan is somewhat landlocked. There's less real estate there. Very congested urban areas in Japan. And Toyota just didn't have the space to be able to expand their business to the large complexes like Henry Ford to be able to accommodate that mass production system. On top of that, there were some constraints put on Japan as a part of the reconstruction effort, just to try to build back the production systems in Japan. So domestic labor was negotiating for higher pay. The government was restricting the ability of companies to lay off workers to make sure that the overall workforce had work to do or had jobs. And then immigrant labor was also prohibited by the government. So Toyota was kind of restricted to the workers that they had, and in some ways limited in how they were able to structure that labor. So as a result of these constraints and these difficulties, the Toyota company needed to find a better way of doing production within the constraints that they had. A small space, not a lot of money, and they needed a way to be able to compete. So they experimented, and what they came up with was what we refer to today as the Toyota production system. I will also tell you, we're going to talk through some of the characteristics of the Toyota production system, or lean. But this method continues to be innovated. So if you're following me on Twitter, or you're looking at some of the articles that I post on my office door, or looking at my YouTube channels on lean, you'll see that companies are continually coming up with new ways of sort of tweaking this original Toyota production system to become better and better. So it's always improving. But here's the basic premise, or some of the basic ideas behind the lean production system. So labor specialization, I put on here as mid. So it's not a low labor specialization where workers know everything about the business like they do in craft production. But it's also not real high labor specialization where workers only do one specific thing. In a lean production system, workers do a variety of tasks within the context of a small sort of mini production area. But they also have relatively high labor knowledge. So it's important for them, for workers to have job rotations, to see different parts of the production process so that every worker knows what has happened before the work gets to them, and where the work is going after them, so that the work that a particular worker does, as they're doing it, they know that their work needs to be able to help to accommodate the work that comes after. And similarly, if they're running into quality issues or production issues in their own work areas, they know the people in the work areas that they need to go to improve previous processes to make their own work better. Product variety, we'll see how this works pretty early on here in the semester, is relatively high. There can be a pretty high variation in the number of products that are made using a lean production system. And a part of the reason why is because the lean production system attempts to move toward a product volume of one. We call this one-piece flow. There are a lot of advantages to one-piece flow, and we'll kind of see how this works as we progress through the semester. Because of that, the space required is relatively small. In a lean production system, we'll typically use flexible, adaptable, small equipment that can be used for a variety of tasks. This is one thing that's going to help us be able to accommodate high product variety, or relatively high product variety. And that's not to say that lean production systems don't use robots or automation or specialized equipment. They certainly do. But where they can, we will use flexible, adaptable, small, very easy to implement equipment and processes. Now, process speed in a lean production system, and this is uniquely different from craft production or mass production, has the process speed is variable, and it is determined by the customer. And we're going to see this as we progress through the semester. In a lean production system, we are going to have ways of visualizing the customer, visualizing what it is that the customer needs and wants. And as the customer requests that work is done, then that's when the work is going to speed up. So depending on the speed or the demand rates that the customer wants, we can either ramp up or slow down our production speeds to meet that. So we're always focused on looking at the customer and what it is that the customer needs. Production lead time, I wrote down here as short. We're going to see this when we get to the unit in the middle of the semester on value stream mapping. Because again, production lead time would be the time from when we get raw materials in one side of the plant until we have a finished product going out the other side of the plant. We call that dock to dock time in lean. And we're going to use low inventory levels to create this lean production system. Of course, low inventory levels will result in less space being used for that production process. And as a result, our production lead times will also decrease. This will also give us the ability to, when we need to make innovations or changes to our products, we can do that relatively quickly because we don't have to work through a lot of inventory to make those changes. Quality and product reliability is consistent, and we're going to use some innovations to be able to improve quality in processes so that it's actually easier to do work the right way than it is to do work the wrong way, and in many cases actually make it impossible to do work the wrong way. So quality is going to improve as well. And then improvement is continuous, and we'll talk about continuous improvement as one of the principles that that is going to help us to be able to make these improvements in these businesses. And this continuous improvement, while we will have, perhaps some industrial engineers, or many of you will be experts in process improvement as a result of taking this class, the actual work for making the improvement will be designed by the workers themselves. So we're going to enable the workers to be able to see problems in their own work spaces and give them the freedom to make those changes to be able to improve their work areas. During this class, we are going to look at many of the principles of lean, and you're actually going to learn and practice using these concepts to improve real business processes or personal processes of your own, things that are important to you. But Toyota, as they began to develop and use their lean system or their Toyota production system, they began to have amazing results. So by 1965, they had won the Deming Quality Prize. Then in 1990, that's really when things turned for lean. Some MIT researchers published a book called The Machine That Changed the World. This is really the book that introduced lean and the Toyota story to the world. And so people then began to see the benefits of using lean principles and began experimenting with that on their own and exploring more about how that they could use these principles in their businesses. 1996, a book called Lean Thinking. So this is sort of a follow-up by two of those MIT researchers was published. And then this is really the book that explained some of the inner workings of that Toyota production system that really helped a lot of companies to be able to move along in their journey. After that, lean acceptance really began exploding. Consultants started emerging that were available to teach companies how to use lean systems and lean principles to be able to run their businesses. And then in 2007, Toyota passed General Motors as the world's largest automobile producer. And as I've mentioned before in this class, companies worldwide continue to implement lean concepts. In fact, lean and Six Sigma, we're going to talk about that in a minute, are some of the concepts that you're going to hear about when you go on interviews with companies, and companies want to be associated with lean. So it used to be, like I mentioned, early 1900s, 1950s, the Ford's mass production system was considered to be world-class, the best in the world. And I will tell you that most companies, most managers recognize that lean and the lean production system, and again, also using Six Sigma concepts, as we're going to see in this class, are considered to be world-class. So companies want to be associated with lean, want to be associated with using lean to improve their businesses. As I mentioned before, very few companies actually are good at doing this, at using lean and lean concepts in their business. And that's one of the reasons why I think this class is important for you. You're going to be able to learn how to use this, how to implement this, and how these systems work so that you can take this to the companies that are hiring you. On a parallel track, Six Sigma concepts were being developed and experimented with around the same times that lean was being developed as well. So in the early 1920s, the Bell Telephone Laboratories was using statistics to be able to evaluate product quality. A consultant, W. Edwards Deming, really refined a lot of the application of the statistical methods. We're going to be using a lot of Deming's processes, applications, principles, tools in this class, and so you're going to be learning how to use those. And Deming actually went to Japan and helped to teach Toyota some of these during the 1950s as well. This term Six Sigma, which we're going to explore in greater depth in sort of the second part of this class, was developed by Motorola, but was adapted heavily by General Electric in the 1990s. And Jack Welch, with the success that he had with General Electric, really really sort of sparked an interest in Six Sigma, and so companies began pursuing this heavily. I've mentioned before, it uses a standardized improvement process, and we're going to walk through that process during the semester. And it focuses on improving individual processes by using statistics. We collect data, we use some statistics to be able to evaluate those processes and where we might potentially improve. And I also want to let you know that the statistics that we're going to be using in this class are not difficult for you to be able to grasp. They're really very straightforward. In fact, the principles of Six Sigma were designed to be able to be used by a wide variety of people. And so a lot of the statistics was somewhat simplified to be able to make it easier to use and more applicable in a wider range of circumstances. As lean principles and Six Sigma principles were separately becoming popular in businesses, and at the time, really, businesses were choosing, do we want to practice lean? Do we want to practice Six Sigma? And so companies were going down that route. There was a college professor that published a book called The Goal. And this book, The Goal, really explained what he calls the theory of constraints. What the theory of constraints does is it looks at production processes and it says that there's always going to be one part of the process where we can get the most gains. There's going to be a weakest part of the process, kind of like a chain, and it's up to us to find the weakest link in the chain. Once we do, if we strengthen that, we can strengthen the whole chain. And so it sounds simple, but there are some principles there, and we're going to actually see this in action. There's one class session that's going to be a lot of fun, where you're going to actually get to see how this theory of constraints works to improve a process. So in the 80s and 90s, that was a time when this theory of constraints was also becoming popular, and there were a consulting group, the Goldratt Institute, was promoting the theory of constraints to be able to improve businesses, and there's a lot of businesses that went that route as well. I will also tell you, in this class, we are blending Lean, Six Sigma, and the theory of constraints. So as you kind of see here in this historical perspective, Lean grew up there with Toyota. Six Sigma grew up with Motorola and General Electric, and then the theory of constraints with this book, The Goal. But these ideas were being developed around the same time. But then it's really relatively recently, over the past 10 years or so, that companies have realized that these principles are not mutually exclusive. You don't choose to do Lean or Six Sigma or theory of constraints, but really all three marry really well together. They all look at processes slightly differently, but in complementary ways. And so really the best way to be able to improve processes is to adapt some of the tools, techniques, principles, mindsets from each one of these together in a very integrated way. And so that's exactly what we are going to do in this class. There was another book written by the Goldratt Institute, the book Velocity. And that was really one of the first sort of novel books that was written to be able to demonstrate how Lean, Six Sigma, and the theory of constraints could really be used together. But that's really the perspective that companies are using today. And so that forms the basis for what it is that we are going to explore during this class.